Professor Thomas live streaming right now. Doing strategies. Strategies on how to be successful in statistics. How should you use your calculator, your expensive, powerful calculator in statistics? Um, a lot of people have been struggling using their calculator. They don't know how to use their calculator. And the first thing I need to tell you is just look at it. Look at the calculator first. And what I mean by that is, let's see how it's set up. Um, it turns out that in statistics, you will notice that there are only a few commands that we'll be using. So these black buttons on the top are your function buttons. In statistics, we only really use two buttons pretty much the whole time. About 90% of the time we use stat, and then we use combined with second distribute. And so sometimes I may say second vars or second distribute. I really mean the same thing, distribute and stat. Now, sometimes we will use other buttons, but it's just for one of the buttons that we originally pressed. But pretty much everything is in stat and everything is in distribute. You get through the course with flying colors if you are familiar with this button stat or and or distribute. And the way it works is let's go inside the stat menu and let's see what's going on in stat. Alright, so the reason why the button stat is so important is because this is where you would go to enter your data into a list. And for you to do your exploratory analysis, I'll call it, or descriptive statistics, where you got to calculate the mean, the mode, and all of these other things, the median, the standard deviation, you have to enter the data into a list. And so when you hit stat, you can do that and edit. You can also do some other commands with your list. You can sort your list in ascending order, descending order. You can clear your list, and you can set up the editor, which is something we'd never really use. Now, what's also cool inside stat is if you go to the next menu option, calc, you have 1 var stats, 2 var stats, med, linear regression, so on and so forth. But we've been using the first one variable stats. So it gives you your exploratory analysis on any list that you want. So if you have a list, that's considered one variable, and you can get a lot of information from that one variable stats. We do not use the others. There will come a time toward the end of the course when we get to regression where you could use either 4 or 8, but there's even a better command in distribute. So the truth is we only really need 1 var stats for the most part. There may be a time where we're doing something else, but those will come up as they come up. So for now, we're going to be using edit to enter the data into your list, and then also calc is important. And then there's also tests. We haven't got to this yet, but it is coming. And a lot of what we do in stats from here on out will be inside this menu option. Okay, let's take a look at the distribute button. Second, distribute. Okay, what's going on in distribute? Well, as you can see, we have normal PDF, normal CDF, inverse norm. We haven't talked too much about this yet, but we did talk about, well, wait a minute, what did we talk about yet? We didn't get to this yet, but it is coming. After the midterm, we'll be discussing normal PDF, normal CDF, inverse norm, inverse T, all of these other distribute functionalities, the t-distribution, probability density function, all of those type. The shy, binomial. We have used the binomial PDF and binomial CDF commands. So we'll be using quite a few from here. Maybe these first four, and then we'll you should also know the binomial PDF and binomial CDF. After that, the Poisson and all these other, so we don't really use. So your calculator is pretty valuable. Now sometimes we might want to graph a statistical plot. So if we have some list, sometimes we might want to create a stat plot, and so all you do is just go to second y equals, and that is actually second brings up your blue buttons. And so whenever you hit the second command, you'll see the cursor has an up arrow. That means now that you're actually pressing the blue buttons there. Okay, and you just follow the screen. It's pretty intuitive. Hit plot, you turn on the plot, choose the type of plot, and then enter in your list depending on the kind of plot you chose, and then you can even choose the marker that you want. And then the catch is, though, after you've entered everything in and you want to plot it, the best way to do that is first either get out of here somehow, either go to second home, or from the screen you were at, go into zoom. Alright, and then look for zoom stat number 9. Now this screen is pretty big. Sometimes you can't see it, but it's there. It's right there. And zoom stat will automatically set up your window for the maximum view, so you can see your statistical plot. And so you don't have to mess around with the window or nothing. So that's pretty much your calculator in a nutshell. There's other times where you may have to do probability combinations and other functions like that, just large combinations. Sure, then you will just use your calculator as you normally would. But for the most part, it's all about stats and second distribute and sometimes second stat plot for the most part. Now there is a command, and let me get out of this. There's another command that on occasion I will use, but we don't really need it because the other commands supersede this other menu, but it's second list. And basically what second list can do, it can allow you to manipulate your list. You can do certain things to your list. If you have a list, you can sort it and do all these other commands. But these commands are kind of getting into another type of mathematics, not necessarily statistics. But if you move over to math, you can do some things with your list. Okay, it returns the min, the max, the mean, the median, the sum of your list, the product of everything in your list, the standard deviation of the list. It's the sample standard deviation, and then also you can get the variance of your list, which is the standard deviation squared. So those are the main commands. For the most part, I just covered about 98% of the buttons that you will be pressing on your calculator to find things. And you got to know the difference between your stat calc versus second distribute. Because sometimes those two commands are key. Stat and then calc, or then second distribute. We go to those quite a lot. So that's kind of just like the gist of your calculator. That's the gist of what we're going to be doing in the calculator. If you can, this is a live stream on YouTube, and you can chat if you want to chat something or text anything about a certain problem or a request of some sort of tutorial on the midterm exams and things like that. Now we can look at some practice problems here. I'll just download this. In fact, what I'll do, I'll print it and send it to OneNote. Alright, let's do a few problems, guys. Here we go. Fake numbers in tax returns, invoices, or expense account claims often display patterns that aren't present in legitimate records. Some patterns, like too many round numbers, are obvious and easily avoided by a clever cook. Others are more subtle. It is a striking fact that the first digits of numbers in legitimate records often follow a model known as Benford's law. Call the first digit of a randomly chosen record X for short. Benford's law gives this probability model for X. Note that a first digit can't be 0. So it turns out the probability of some number, the first number of some number of a legitimate record will be, the probability of a legitimate record would be 0.301, or so on and so forth. This actually has the highest probability, and the lowest probability, it looks like 9 has the lowest probability. So if, for example, if you're filling out a tax return and your first digit in the tax return is 9, the chances are it's not a legit number. It could be a fake number of some sort. Well, the first part in this question is let A be the event that the first digit is at least 3. And so what we're going to have to do is calculate the probability of A. So calculate the probability that the first digit is at least 3. Well, at least 3 means then that, let's see if we can get a, here we go. Let's get a marker up. So at least 3, then that's 3, 4, 5, 6, 7, 8, 9. That's at least 3. All I got to do is add them up, and that would be the probability, because this is an OR statement. What is the probability of 3 or 4 or 5 or 6 or 7 or 8 or 9? What is the probability of A? Well, I already know that all of the numbers totals one whole, because this is a probability distribution. Now, I could add them all up and figure it out, but what I'm going to do is subtract the sum of these two from 1. All right, little shortcut trick to do that. Let's get the calculator out. All right, and let's move it down a bit. Yeah, here we go. And what I'll do is bring this down a bit And if I take the sum of those two, that's just going to be 477. So I'm going to do 1 minus 0.477. Okay, do you see how I got 477? But I added 1 and 2 there. So it turns out the probability of A is, is it 470, 570? What's that? 523. Now, what about the probability of A? And what is A? So probability of A is 0.523. What is the probability of B? Well, B is the first digit is even. Okay, so if the first digit is even, we have 2, 4, 6, 8. 2, 4, 6, 8. And I got to calculate that. So all I'm going to do is take the sum of all of those numbers there. So I'm going to clear that out. I'm going to do 0.176 plus 0.097 plus 0.067 plus 0.051. And I'm getting 0.391. That's 0.391. And now the question is, what is the probability of A or B? In other words, what is the probability of getting a number that's even or at least 3? Well, at least 3 covers them all. So it's really just every number except 1. The probability of A or B getting a digit, that's going to cover 2, 3, 4, 5, 6, 7, 8, 9. There's a lot of ways to do this, but essentially it's simply just going to be the probability of 2 through 9. This covers all of them. And so one way I can do that is subtract 1 from 0.301. I can add up all of these, or I can add A and B together and then subtract the overlaps, which in this case are an overlap, anything with a check and a circle. We can subtract the overlaps. But what I'm going to do is subtract 1 from 301. And what do I get? I get 0.699. Find the probability that a randomly selected student is a nursing major. So it's going to be the sum of all the nursing majors divided by the total number. Find the probability that a randomly selected student is male. Well, the sum of all the males is that number, and that's out of the total number of students. Find the probability that a randomly selected student is a nursing major and male. Well, it turns out that there's actually 151 nursing majors that are male out of all of them. And then the question is, find the probability that a randomly selected student is nursing major given that the student is male. So out of all the males, how many is a nursing major? what we could do is going to be 151 out of 1255 this time. It's restricted given that the student is male, so we have to look at all the males, and it's the ratio of the nursing majors versus the non-nursing majors in that set. Let's do another problem. In this problem, this is a binomial theorem probability problem, and it says a survey indicates that 41% of women in the US consider reading their favorite leisure time activity. What I'm going to do is create a probability distribution table. And let's see if we can get a nice probability distribution. And so now we have a lot of different cases. In fact, let me see. There are 4 women, and we want to know, find the probability that exactly 2 of them respond yes, find the probability at least 2 of them respond yes, and find the probability that fewer than 2 of them respond yes. Well, first, I'm just going to calculate the probability of every event. Exactly 0, none, 1, 2, 3, 4. So how do I go about doing that? What I'm going to do is first clear out my calculator there, and I'm going to use my second distribute button. Second, distribute, and we're going to go down to binomial PDF. It is A. And I have on Stat Wizard, so when you have on Stat Wizard, it's a mode in your calculator. It will enable you, it will prompt you as to what to put in. So the trials that we have is 4. The probability is 0.41. And my x value, I'm going to do 0 first. And so what did I get when I got 0? 0.121. So I'm going to put in, for my probability there, now I want to do it for exactly 1. So I'm going to bring it back again, second entry, and instead of exactly 0, what about exactly 1? What about exactly 2? What about exactly 3? Actually, that was not exactly 3. Okay, so for exactly 1, I'm going to write this down. This is good stuff. We were able to get a bunch of probabilities. For exactly 1, we're getting 0.3368. I only needed 3 there. But for exactly 2, we got 351. For exactly 3, and for exactly 2, I got 0.351. For exactly 3, I got 0.162. Now the fourth one, I could figure it out because I know that all of them will add up to one whole, and I can subtract that from there. But I'm actually going to do it in the calculator. So I'm going to just do a second entry, and then put exactly 4. 0.028. So the chances that all 4 of them in my group read as their favorite hobby, the chances of that happening would be 0.028. So there it is. That's my complete binomial distribution table. Now I can answer any question now. Question 1. exactly 2 of them respond yes. That's going to be 0.351. 2. At least 2 of them respond yes. Well, at least 2. That's 2, 3, 4. I'd have to add them all up. I'd have to add it all up. I'm getting, let's see, if I add 2, 3, 4, I'm getting 1, carry the 1, 14, carry the 1 again. 0.541. And then for the third choice, fewer than 2 of them respond yes. Or fewer than 2, meaning 0 or 1. So I have to take the sum of 0 and 1. And that would simply be 0.457. And what if the probability was they all said no? So that does mean that 0 says yes, and that probability would be 0.121. Okay, I hope this was helpful. We're probably going to wrap it up here, folks, unless there's any other questions or comments. Just let me know, and we're going to try to help you get through this.